and many of them have moved beyond the range of telescopes, yet the universe you observe has never ceased to be abundant. As fast as the ancient galaxies move away from us and disappear from our sight, they are replaced by an equal number of new galaxies, continuously forming from new matter, at the same speed necessary to maintain the same density of galaxies in space. We understand from the theory that the universe is a system that organizes itself to be in a state of precise and complete balance. While you greet a friend, some galaxies may have moved 2,000 miles farther from Earth. At such speed, these galaxies move away from each other, swimming in a vast, expansive space where galaxies appear as tiny dots or as few scattered, sparkling diamonds, separated by vast areas of empty space that have no beginning or end. And as the galaxies float and rotate in magnificent harmony, they appear as those colored spheres and luminous bodies, gracefully and elegantly moving together like a single body where cells are born and die without anyone noticing. Similarly, stars within galaxies are born and die. Some stars glow, others explode, and some burn steadily. Giants and dwarfs emerge and form in an ongoing process of elemental evolution. As scientists say, the first star was born from fragments after the initial separation from the original cloud, followed by sequential fission from the secondary cloud to form fragments, each fragment spanning thousands of light years and containing billions of tons of matter. In the beginning, stars are formed from gas or clouds of gas, a gaseous core. Then these gases are used to produce billions of other stars. Then they fade, and as they fade, they lose part of their matter, which returns to the gases between stars to form another generation of stars. The oldest stars in our galaxy began to shine about 7 billion years ago. Since that first epoch of star formation until now, around 100 billion other stars have formed, and since each star must be accompanied by planets, the Milky Way alone contains about 100 billion solar systems. Knowing that the universe contains 5 million other galaxies, the likelihood of life existing in our galaxy or in one of those galaxies is very high, as scientists assert. The colors of stars vary according to the different temperatures on their surfaces, ranging from red to orange to yellow to white to blue-white at the highest temperatures. And from the color, one can approximately determine the star's mass. Stars change and evolve according to natural laws, as evidenced by the interconnected facts and conclusions derived from scientists' theories and observations. Stars begin their childhood phase when they form from a shapeless gaseous cloud, then become a stable, glowing, organized sphere. They then enter the aging phase, expanding and swelling into a red giant, beginning to shed their material, billions of tons of it, and eventually shrinking into a dwarf. The transition from childhood to old age for a star takes between 50 million to 10 billion years, depending on the star's mass. As the star passes from childhood to old age, its color changes from white to yellow, then to orange, and finally red. After this, it shrinks and becomes a black dwarf. When a star reaches the black dwarf phase and completely fades away, it leaves behind matter from which another star can later form.